Hello, and good morning, good afternoon, or good evening, depending on where you're joining us from. Welcome to Engineering for Change, or E4C for short. Today, we're very pleased to bring you the latest in E4C's 2013 webinar series. Today's webinar was developed in collaboration with Practical Action, and our guest presenters are Liz Bates and Sam Shiroff. My name is Katie Welford, and I will be moderating today's webinar. When I'm not doing this, I work for Practical Action, where I am the Project Communications Coordinator. Practical Action is a unique international development charity that uses technology to challenge poverty with poor communities around the world. So I'd like to take a moment now to tell you a bit about today's webinar, Indoor Air Pollution and Smoke Hoods, Lessons from Nepal. One of E4C's topical focus areas is health, and we're particularly concerned with capturing and sharing lessons learned. To do so, we've invited today's presenters, Liz Bates and Sam Shiroff, who work in partnership with Practical Action on the Healthy Hoods project. Liz and Sam, thank you very much for joining us today. And before we get started, I'd also like to take a moment to recognise the coordinators of the E4C webinar series generally. Jana Aranda of ASME, Holly Schneider-Brown, Victoria Chung, and Alex Torres of IEEE, who work on developing and delivering the webinar series. Thank you very much. If anybody out there has questions about the series, please do get in contact with them via the email address visible on this slide, webinars@engineeringforchange.org. Before we hand things over to our presenters today, we thought it would be a good idea to remind you about Engineering for Change and who we are. E4C is a global community of now over 12,000 technically minded individuals such as engineers, technologists, representatives from NGOs and social scientists who work together to solve critical humanitarian challenges, whether in water, energy, health, agriculture, sanitation or other areas faced around the world today. We invite you to join E4C by becoming a member. E4C membership provides cost-free access to a growing inventory of field-tested solutions and related information from all the members of our coalition, including professional societies like EWB USA, IEEE, ASCE, SWE, and ASHRAE, and academic supporters like MIT's D-Lab, plus international development agencies like USAID and us Practical Action, as well as access to a passionate, engaged community working to make people's lives better all over the world. Registration is easy and it's free. You can check out the website, engineeringforchange.org, to learn more and sign up. The webinar you are participating in today is one installment of the Engineering for Change webinar series. This free, publicly available series of online seminars showcases the best practices and thinking of leaders in the field who bring leading-edge technology and solutions to bear on global humanitarian and development challenges. Information on upcoming installments in the series, as well as archived videos of past presentations, can be found on the E4C Webinars webpage, which is engineeringforchange-webinars.org. E4C's next webinar will be on the 29th of January at 11 AM EST with Steve Daniels from Makeshift on makeshift communication, designing for scattered signals. To register, please visit the E4C webinar page. So, a few housekeeping items before we get started. Let's see where everyone is from today. It would be really great if in the chat window you could type your location. Any technical questions or administrative problems should also go in the chat window. Feel free to send a private chat to Holly or Jana. You can also use the chat window to type any remarks you might have. During the webinar, please use the Q&A window located directly below the chat window to type in your questions for the presenters. If you are listening to the audio broadcast and you encounter any troubles, try hitting stop and then start. If that doesn't work, you can use the call-in number for the teleconference. Or you may also want to try opening Web apps up in a different browser. Following the webinar, to request a certificate of completion showing 1 professional development hour for this session, please provide your full name and date you completed this webinar, as well as the code that we will give you at the end of the session. Send this to eab-ceuadmin@ieee.org. And so, now we can move on to today's first presenter, which is Liz Bates. Liz is a household energy specialist who has worked in indoor air pollution for around 15 years. She has a background in mechanical engineering, and Liz used to work here at Practical Action as a project manager before becoming an independent consultant, working with several organisations, mainly on smoke alleviation. Over to you, Liz.
Thank you, Katie. As Katie says, I've worked for a very long time in household energy and managed a couple of projects for Practical Action on smoke health and household energy before branching out as an independent. Before we start this seminar, I would like to try to flag up to you the fact that smoke hoods are not just a technology on their own. They are a technology which can be used with stoves, particularly artisanal stoves, which may be very good at supporting the environment, but which do not remove a lot of smoke. So if you're a stove producer and you'd like to be able to produce a clean, fuel-efficient stove, then this seminar is for you. Using a hood can allow local production and local manufacture and achieve both smoke reduction and environmental improvement. So what's the scale of the problem? Recent figures from the Global Burden of Disease Study, which is the Bill and Melinda Gates Foundation, has just published, now this is mid-December 2012, new data for the amount of people who are adversely affected by the effects of smoke. 2.8 billion people use solid fuels for their main cooking fuel. This leads to 4 million premature deaths per annum globally, which is, I think this figure used to be just under 2 million, so this is a very large increase. And you can also see 0.5 million of those are childhood pneumonia cases. Those who are looking at this will realize that this is a lower figure than the figure that used to be stated. But if you look, this is only childhood pneumonia cases. Sometime in the not too distant future, that figure will be updated to account for other causes of child mortality as soon as these figures are verified and updated. So that is currently the situation. Nepal is a particular country which suffers from a real problem for various reasons. One is that 85% of Nepalese households cook with smoke, cook with biomass, so they get a lot of smoke. They get even more smoke because when people are living at high altitude, they need space heating. And they close doors, and they close windows, and after they've cooked, they leave the fire on, and they sit close to it, inhaling the smoke as well as enjoying the heat. They also want something where they can sit around a fire. So just enclosing with a stove will not always be what they want, because if you have a stove that is completely enclosed and you're cold, you go to another fire in the same room. And the figures, which are earlier figures in Nepal, show that nearly 750,000 people die annually prematurely from household air pollution. I'm not sure that I've got that number right. So 7,500. So let's look at the technologies that people adopt. Rather than thinking about what's a good technology that people want to introduce, let's look at what people themselves want. Because if they don't want it, they won't buy it. If they don't buy it, there is not enough money going round in order to give everybody a good technology, and what's more, they're not likely to use it. So, forgetting about smoke hoods for a minute, people want something that's desirable and effective, So it has to be what they want. It has to remove smoke, or we can produce something very nice that's not doing the job. These two, affordable and long productive life, are very closely linked, because if you have a product that only lasts a year and it costs you $10, then provided you can get the upfront finance, it's much better to buy something which is more expensive and is worthwhile for a long time. Something has to be flexible, because people have particular needs in particular areas. And if you can, and I'm not always saying that you should, but if you can make something locally, then it is also easily maintained. And to create that, you need an enabling environment. Good design skills mean that not only can you make something which is desirable, but it is effective. A loan structure can mean that something which would not be affordable because of the upfront costs suddenly becomes affordable, provided people want it. You need good promotion so that people understand what the problems are. Maybe not just health, but also the other benefits, the time benefits, the cleanliness benefits. And good promotion is something which an entrepreneur themselves might not be able to produce. And NGOs are very well placed for this. Good manufacturing skills need to be available, but they only need to be good enough for the technology which you're talking about. And the supply chain means that when people want something, they are not being held up for several months by not having the steel to make it, by not having the fuel to burn. So the supply chain is very much part of the overall package. But the big thing, and it's one that I'm reiterating, is that it should be demand-driven. People must want a technology. It should not be imposed on them. So let's go back to the product. So this set that I put on the left-hand side. And let's go back to smoke hoods and see how they fit in. Okay, we have introduced these into Nepal, or rather the Nepal Practical Action Team has been working very hard with local communities. Is it desirable? Well, they've got a long waiting list at the moment. And this is for smoke hoods which are being paid for in full at the current steel prices. The things that are not being paid for are things like promotion. Is it effective? Well, the current smoke hood removes 80% of residual smoke from any stove that's in place. And here on this picture, you can see a traditional tripod stove, which we tweaked a little bit by putting mud around the sides and a bar across the front to make the primary air go in nicely. People pay for it using locally managed revolving funds, and they have to put in quite a lot of upfront money before they become part of the scheme. And there are 200 people waiting. We started the scheme in Kenya, and some of those are now 10 years old. I'll show you a picture in a minute of how well they're doing. About a few years back, but still 5 years old. They are flexible, so whatever stove people want to use, or if an NGO is introducing a particular stove that is very environmentally friendly, the smoke hood can very often be put on top of the stove. This particular smoke hood can be made locally by local artisans, and as I say, it achieves 80% reduction. Show me another stove which can do that that's locally made. And it's very easily maintained. And because the artisans are local people who have been trained and are training others, then that maintenance can be continued. So let's look at one of these original stoves. And this was one that we started off in Kenya. And these two lovely pictures are of a lady who has her stove built. The left-hand picture shows when it was being installed, along with grating on the windows. And the right-hand picture shows it about 5 years later, when I went back to visit it. And as you can see, the smoke hood is doing really rather well. The window's been fixed, of course, but the smoke hood itself, I don't think that most people would say, gosh, that's on its way out. And that was after 5 years. But it was removing, I think, on average, around 63, 64% of the smoke. And when Bosch Siemens came along, they said, let's get the technology right. Let's get the expertise in. And here I wanted to mention a lady called Stephanie Pohl, who works for the Bundeswehr University in Munich. And Stephanie she works on fluid dynamics, and she looked at the flow of smoke going through that smoke hood. She started with this hood that looked very much like this one, and she started doing the maths on it. She did it on the smoke hood, she did it on the cowls, and she increased the smoke reduction to about 80% of all the smoke. So all the smoke that was put out from a three-stone fire or from a tripod stove or from many other stoves, 80% of that was going up. And as you can see in the corners, little tiny bits were getting, the earlier pictures showed little tiny losses escaping. And she worked on the maths until this stove is now very, very well optimized. Not only that, but this stove is still manufactured using hand tools. It's manufactured up on the mountains. They take up roll steel and they use hand tools. So no problem. It is highly technical. It is also locally manufactured. So where have we got to? Since the project started in Nepal, around 2,000 smoke hoods have been installed. Now that's from way back, the earlier projects that I was talking about that I worked for at Practical Action. Of these, 526, as counted in November, were using this latest design that averages 82% reduction. And there are 300 people on the waiting list. That was in November 2012. Guys have been trained who make them, they're local blokes. I think there's now one woman involved in making them. And the person who's doing a lot of the training is somebody who started off with the first study and is now supporting the training. 82% average reduction. We've only got the carbon monoxide measures, but you can imagine the particulate reductions will be very similar because we're using the same fuel. And these are very close to WHO standards for maximum safe quantities or maximum acceptable quantities. There is a suction on the hood, and it is reducing, it makes the flame burn very well. And we're getting about a 30% reduction in fuel, and that has been measured. And currently, there are 18 cooperatives in the present study. The payment levels are very close to 100% because these are people who know that their neighbours will get a smoke hood when there's some more money in the fund. So very small start of funding, and then as people repay, more people get a smoke hood. There's a study at the moment going on which will look at this process and anything which is causing problems, anything which needs to be optimized, why it's working so well, anything to be changed. So what's happening at the moment? Well, these 300 smoke hoods will continue, but as Practical Action walks away from that area, there are all the pieces in place for this system to continue. The exit strategy is part of the project. Currently, Practical Action in the UK is putting together a website which will allow anybody else who wants to use a smoke hood over their stove to download a design. We had hoped that it would be ready for this webinar, but it's not there yet. But it means that you put in the size of the family, the kind of materials, the kind of food they cook, the size of the pot, and it will give you a printout of a design with the dimensions on it that will make a smoke hood that will give you 80% reduction. And there are 3 link studies which are going on in Nepal. So this is what's happening in Nepal. Appropriate and efficient stove study, a review of the cooperatives, and the potential for smoke hoods in the rest of Nepal. And there is a Nepali manufacturing manual being written. Currently the instructions are in English. I'd just like to pull back just a little bit to this appropriate and efficient stove. They don't have to be Practical Action stoves. They could be anybody's stove. So if you're wanting to put a smoke hood over your artisanal stove, which is very fuel efficient, but perhaps is giving out too much smoke and is causing more health problems than you'd like, then think about putting a smoke hood over the top. From practical action's point of view, into the future, possible expansion in Nepal, hence the survey, possible expansion into other countries. We have had experience. This lady on the right is Tanzanian, and you can see there the walls are made of mud because we don't want the heat radiating into the room. It's hot enough already, thank you. So in this case, it's a more enclosed stove, an opaque stove, and mud walls, and most of the heat, as well as most of the smoke, goes out through the roof. There is an argument for industrial manufacture if it can reduce the cost, where you would have a template and the shapes would be punched out, mass-produced, taken up to wherever they were to be built, and local artisans who are somewhat less skilled than the ones who have been trained in Nepal would be able to put them together because all the dimensions would already be there, and that's something which would be interesting to investigate in other countries and in other communities. And as I say, as from this picture you can see that that you can make it with reducing the price and with reducing the heat radiation, if you don't want the heat radiated, by using other materials. So, in conclusion, what have we got? Oh dear, let's try and go back. Okay, a smoke hood, a basic stove, paid for using revolving finance, using affordable locally made technologies that reduces CO, we know already, to recommended WHO guidelines. We'll know very soon that the PM, the particles are also reduced, and which saves biomass resources and doesn't require a subsidy. I don't think there are many things which you could do that would alleviate smoke and reduce the pressures to the forest unless you look at this combination. And there's a big thank you here. The wonderful communities who have trusted us and worked with us and are now queuing up for these smoke hoods. The practical action team in Nepal who have worked quite tirelessly with a local NGO called Gareto, which means into the countryside. It's a pathway, a Gareto, which leads into the countryside. And I've been privileged to be part of their work. Bosch Siemens, for crowdfunding this project, and for Sam, whom you'll hear, who has been encouraging me on to greater things, and it certainly has been enjoying our wonderful Nepal team. DEG, which is a German government funding, which helped, and the Bundeswehr University, the Department of Thermodynamics, and Stephanie, who did the wonderful fluid dynamics and managed to achieve these levels for the communities. And finally, thank you all for taking part.
Thank you very much, Liz. That was excellent. And so now we'll just move on to today's second presenter, Sam Shiroff. So Samuel Neil Shiroff is the Senior Sustainability Specialist at the BSH Home Appliance Corporation, which is the North American subsidiary of Bosch and Siemens Home Appliances Group, located in Munich, Germany. His responsibility is to develop and lead the sustainability strategy of the company. Prior to this role, Sam was with BSH in Munich and responsible for the global corporate social responsibility projects for the company in developing countries for establishing and implementing the business model based on the clean development mechanism of the Kyoto Protocol and promoting appropriate household energy efficiency policies in Europe and beyond. Thanks very much for joining us today, and I'll hand over to you now, Sam.
Great. Thank you very much, Katie, and thank you all for attending. It's a great attendance thus far. I see 33 people total. I'd very much like to thank Engineering for Change and particularly Practical Action as well for organizing this, and also Liz for pretty much covering everything already. So my part won't necessarily last so long, and I'll ask for your forgiveness for going quickly through slides, which I do a little bit of repetition on what Liz has already said, and will clearly be available after the conference, as far as I know. So I'm flipping charts here. I'm sorry. For some reason, I thought I was going to change charts there. So I'll start out with the standard presentation is who the heck is BSH. We're actually a joint venture between two much larger German companies and have been around for about 45 years now, but a completely separate company with global operations. We're the #1 home appliance manufacturer in Europe, #3 in the world, although we may soon be #2, and have factories in over 14 countries, in operations in over 70, and about $10 billion, or euros, I'm sorry, in sales in 2011, and in fact around the same in 2012. You probably have heard of the brands that we sell, at least the main two, and if you live in particular places, maybe the others. And now I'll get to the heart of the matter. Basically, for BSH, obviously the conventional products that we sell are really for people who are living in industrialized countries or are the more wealthy people in developing countries. But at the same time, we recognize as well that a very large percentage of humanity doesn't cook with the types of machines that we build on a daily basis. And we felt that we could nevertheless use our core competence as an appliance manufacturer with a lot of engineering capacity to make a difference in this area. We've worked on an improved cook stove, and out of that focus on the improved cook stove grew relationships with a variety of organizations, with the German GIZ, with the Global Alliance for Clean Cook Stoves, and we got to meet and learn people at Practical Action in a way that made it very interesting for us to address different challenges. To this chart, this is one of my favorites, and it just de-emphasizes how much of an issue indoor air pollution is in what otherwise people might think is an environment with this clean, fresh air. I don't think I need to go into great detail about how cook stoves can improve the quality of life, improve the quality of air for either this group or for having to repeat what Liz said. So I'll move on. Also, this chart has some level of repetition, but it's really the background and the understanding that we use to help educate internally at BSH and to talk about externally as well. What are the reasons? What are the causes? What are the potential solutions? And where is it that we're going to focus? And then to really take the step to say, how can we use our some of our advanced engineering capacity to begin to address the issue? And one of the interesting things is that, if you look at chimneys, chimneys have existed for almost since fires have existed, and people have been channeling them outside and outdoors to get the smoke out of their houses. There are norms and standards that exist in Europe for several hundred years now, but they always assume that the stack is at least 3 meters high. And obviously the dimensions of the chimney play a very, very big role in the overall performance of the chimney. And there really don't exist or haven't existed norms for a stack that was less than 3 meters. And that's really where it is that we started. And working together with Practical Action. And by the way, on a short aside here, when I first started working for Practical Action, and although I have some nonprofit background, Liz really gave me a hard time. She drilled and made at me and made sure that that not only was BSH serious about doing this, but that I personally was committed, and I very much appreciated that as part of the overall relationship with Practical Action, making sure that it was an eye-to-eye relationship, making sure that we were all on the same page as far as how it is that we were going to manage that. And been a fantastic, really a fantastic experience for me personally and for the company. But we also have, as a partner, the Bundeswehr University, which happens to be just a couple of 100 meters from the headquarters of DSH in Munich, and that made it particularly convenient for some coordinating purposes. We've worked with them in the past on other thermodynamic issues, and really using some capacity that is perhaps otherwise dedicated to other issues for development and progress in a variety of places around the world that might not normally benefit from those types of resources. So the goals of the project were really to first design nodes, establish clear guidelines, creating a functional internet accessible overview, and that website is available, and we have it linked here. And there's still a few ticks that we're working out on, but overall you're able to build your own smoke hood. And of course, the question becomes, what's in it for BSH? Now, we wanted to create this also as a social enterprise. Obviously, it's always necessary to achieve not just the social and environmental balance, but also things that aren't economically self-sustaining stop at some point. So to emphasize what this said, people have to be able to afford the smoke hood, they have to want it, and we have to figure out a business model that allows it to run independently. But for us, it really was about supplying the technology and, of course, gaining the added value of people hearing about us and listening to see that DSH has made and is using our core competence to make this type of commitment that's a little bit outside of our daily business. So just to give you an idea of how the project management worked, DSH worked together and we got what's called a public-private partnership from the DEG, which is a development arm of the KfW Bank. And we worked with them in the past, and we're really thrilled with their cooperation. And they're also very pleased with how this is developed with the university and with practical action. Really, and I think that the way that this looks in terms of a hierarchy, I think, is a little bit misleading, because I would say that most certainly in terms of decision making and orientation about how we're going to manage things, the practical action and DSH are really at I&I level. And then working locally in Nepal with Laredo, that we're then in charge of getting the manufacturers trained, making sure that the finance was in place, and getting the product to the end, selling the product and getting the product to the end users. So here I just I wanted to give you an idea of sort of from the technical to the field. This is on the left. There is that young lady, Stephanie Pohl, who really is brilliant and built a chimney, then built a fire in the chimney, and was able to do things that I certainly only begin to grasp and understand, but she really is and has played a fantastic role in doing all of this. Just had a baby too, so all of that together, and then you go to see from where, from the computer to the field, where with the goal of always making the advanced technical design easily translatable to the locally available tools. The model, it has to begin in as much as it might be a great product. If people don't either know about it or know why it might be useful to them, won't want it, and that goes for anybody, anywhere. So it starts with awareness raising, moves to marketing it, getting maybe some of the most prominent villagers to try it out, and helping people to understand how it would be not just pleasant but also useful and healthy for them, making sure that it can be built locally to generate local economic added value, actually building it, building and installing it, making sure that the quality meets high standards. People don't want something that they've paid a significant amount of money for to break or to rust or to not function properly. and then to establish the appropriate and adequate financing to make sure as many people can get it based on their incomes as we possibly can manage. So these are the stats I think that Liz has already mentioned these. Our goal was 750. We're well over 800. Our first revolving fund basically has been exhausted, and we're in the process of looking for some additional funding, some additional expansion opportunities, and of course as the fund revolves, more people will have the opportunity to take advantage of it. So once again, a before and after picture. I appreciate your attention and really look forward to some questions if there are any, and pass the presentation volume back to either Katie or Holly.
Thank you very much, Sam. That was a really interesting presentation. Just for, is it back to me? There we go. We're now going to be open for Q&A. So if anyone listening has got any questions, if you can type them into the Q&A box, which is at the bottom right of the screen, and if they're directed at either Liz or Sam, if you can just make that clear. And just briefly then, if you want to find out more, you can explore the Healthy Hoods tool and a bit more about the project. As Liz said, the tool is still, the online tool is still being worked on, but it's still there as in its current form, so you can still explore it and try it out. So if you go to healthysmokehoods.org, if you want to find out more about practical action, you can visit practicalaction.org. And another website which might be of interest on the topic of indoor air pollution and clean cooking is the Global Alliance for Clean Cook Stoves, or GAC as it can be known, and you can find that at cleancookstoves.org. And if you did have any other questions that you wanted to ask either Sam, Liz, or myself, and in particular if you wanted to be put in contact with the full team from Practical Action, then feel free to send myself an email or direct questions to Liz and Sam. So we've got some questions coming through. I'm just going to ask a question myself, actually, very selfishly as the moderator, to probably to Liz, which is with indoor air pollution and cooking, largely the risk is for women, as they tend to do most of the cooking. So what was interesting, actually, is you're saying that obviously in Nepal, a lot of that pollution comes because not just from the cooking, but people sitting inside and wanting to stay warm. So are there, I suppose, not decreased risks for women, but kind of increased risks for men in the situation of Nepal that's different from maybe Kenya, where you don't sit inside necessarily to keep warm?
Nepal has got a problem because there are a lot of households living at high altitude. So the answer to that is yes. Interestingly, this global health study shows that there are men, a very large number of men with risks associated with respiratory infection. Some of that will be due to smoking, some of that will be due to it being compounded by other risks. But yes, most of the problem is for women and for small children, because women tend to wear a scarf with the children on their backs to keep the very small babies safe. And so as they bend over the fire, the children inhale. There are also small children running around, and the smoke hood acts as something of a barrier to that happening, as well as keeping the child's face away from the smoke, which is very considerably reduced.
Okay, thank you very much. And so another question, and if I sent this one Sam's way, which is from Rabindra Nath Bakarai, I believe. Sorry if that's the wrong pronunciation. So it's a question about the hood design and saying, is it a generic design or can it be tailored to specific household requirements?
Yeah, it's basically we've created not a design as much as parameters. And obviously, there are some basics that the way a smoke hood needs to look with the stack and with particular dimensions. But the website itself, as well as the blueprints, basically set up a set of proportions which allow for, and also with maximums and minimums that allow it to be exactly that, specifically tailored to a given household, so as to achieve the results that the household may wish. Now, I would say that obviously there's some limitations. The base of the smoke hood is, for a very large family where they're cooking with multiple pots with multiple fires, may need to be large. However, there's a significant limitation as to how large that can be and how high the stack needs to be. So the larger the base, the higher the stack needs to be to create the necessary pressure differential, so as to allow for the draft to essentially, let's say, suck, although that's not really the case, but to pull the enough air up through the chimney and get it out of the home. So what you would see if you go to the website is an opportunity to put in a variety of different categories in terms of how big is your family, how many pots do you use, how big are the pots, what types, how high is your roof. And I would say that it gives you a pretty good estimate of what an effective design would be under the given limitation.
Great, thank you very much. And this is a question from Millen, very quickly to you, Liz. What do you mean by drudgery reduction for women?
Oh, gosh, goodness. Biomass is a nightmare in terms of time, and I think if you find any of the surveys, you'll find that time saving is one of the great benefits that women cite. One of the things we found from the first survey in Nepal was that when we asked women what the problems were associated with gathering fuel, some of them said time, some of them said hunger, and some of them said falling on rocks in the steep slopes. But hunger is one, I think, which explains how hard it is to gather enough fuel. So that drudgery is reduced by reducing the amount of fuel that needs to be gathered. You can also, of course, gather less high-quality fuel because the smoke will be vented, although I recognize the greenhouse gas situation. But the pots are also, the room is also cleaner because the smoke, if you look at any of these pictures that we produce, inside the smoke hood is very, very black. In the room is not black, and it used to be. And the clothes are cleaner. Interestingly, the thing I noticed most was that the children's faces were cleaner. So there's all the associated washing, soot, fuel gathering, cleaning, and it's all much reduced by using smoke hoods, especially with improved stoves, it must be said.
Mm-hmm.
Yeah.
Great. Okay. Thank you, Liz. And then we've had a number of comments from Alex Dunn, I believe it is. So we'll just read one of them out, which I think they are. He's arguing that an open fireplace has an inherently low combustion efficiency, and therefore, in order to save firewood, a stove must have an enclosed combustion chamber with a door to close it, and able to adjust the airflow as well as the outgoing air. So I think, I believe it's a he, is arguing that therefore you must have a closed fire and not an open fire. Would you like to just respond to that?
Yes, surely. Hello, Alex. I think we met at a meeting in Nepal and we had a similar discussion. An enclosed fire is, and I know you have built an extremely high-performance stove, which I think we featured in Boiling Point. But having said that, an enclosed stove is very good for those who want to have an enclosed stove. For those who want to enjoy the radiated heat, which people want in the mountains, for those who do not want an enclosed stove for any other reasons, and I'm not telling them what technology to use, then a smoke hood will be very useful. If you want to put that enclosed stove under a smoke hood, then when you take a pot off to stir it, or when you're not using both pots, or for all the leakages which you nevertheless get if you've got potholes, then if you've got a smoke hood, it will reduce 80% of your residual smoke anyway. So this is not a them and us situation. This is a put a smoke hood over whatever you feel is most appropriate for people to cook and things which people want to cook, and it will make that stove even better.
Great, thank you very much.
Yeah, can I actually add to that? I mean, we encourage first and foremost, and I think that Liz also mentioned this in her presentation, improved cook stoves. That the fuel savings, the indoor air pollution reduction when it is a clean cook stove, and also reduction of drudgery and all of the other issues mentioned and that can be achieved with the smoke hood. The cook stove, and it's often portable and less expensive. We recognize that, and if you even go to the website and hear anything that we said about this, realize that that's for us also a priority, and that we emphasize that. Really, the smoke hood is either as part of a system where people want an open fire either all of the time or some of the time for the reasons that we mentioned, or for any variety of reasons, can use in conjunction often with an improved, let's say, lower cost or almost disposable improved cook stove, if it's just a tripod or something that's a lower cost, and have something that's permanent there in their household that works as well. So we look at it, and then I often compare this to some of our conventional products. We sell not just stove or an oven or a range, but also the ventilation as well. And so to look at this as a systematic approach, but we certainly aren't putting this in any way, shape, or form ahead of improved cook stove, which we recognize as members of the Global Alliance. Obviously, both BSH and Practical Action have worked on improved cook stove, so it's not really an either-or issue. It's both, or in the circumstance that an improved cook stove is not acceptable for whatever reason, at least get the smoke out, because it has such a huge amount of impact on the health of women, the health of their children, the health of their families, and development in that context in general.
That's great. Thank you, Sam. So I've got I'm just going to read two questions now, which I think sort of complement each other. And maybe if Sam, you can answer first, and then we'll go to Liz. So James Fathers asks if you can just tell us a little more about the manufacture in the local context. And then John Critchley, I think it is, comments or asks, sheet metal must not be readily available and therefore has costs associated to it. Why not make a smoke hood out of local rocks, like a fireplace, and use the metal only for the chimney to reduce costs? So if we can take that to you first, Sam, and then Liz as well.
Sure. Well, I mean, in terms of the local manufacturer, I'm not an engineer, so I can only tell you what I've observed. But basically, in the villages where I was, there were manufacturers who were trained, and as you saw from the picture in my slide, essentially they were able to take sheet metal that was delivered from the local town with a tractor or on, even in the rainy season, delivered with whatever animals, that were donkeys, I think, that were transporting them to the village. And they were able to use metal cutting scissors and hammers and very simple rivets to meet the specifications. We had our local partners trained these individuals both to build the hoods according to the design as well as install them. And it provided good-paying jobs for local men. And I'd actually say, at least where I was in Nepal, near Dorado, one of the things that struck me in the villages were that there were almost no working-age men. And I was told that this was because there's no work. They either all go to Kathmandu, or a lot of them were in somewhere in the Emirates or other cities in the Gulf, working and sending back money, wanting to build a house, wanting to return to their villages. And so this is one of the few economic opportunities, to a certain extent funded by some of those remittances, but nevertheless still providing local jobs and local economic activity. In terms of use of alternative materials, we actually really looked into this, trying to find what could the base be made of. So now, in theory, the dimensions are what's important, not the material. So using stone or building it with stone might be possible, and some experimentation is probably in order at this point. We hadn't gotten that far along in the project, simply because our goal was to use the funding that was available to create the design, to create the communication so that people had access to it, and to really test the design in a number of households and see if we generated an adequate amount of demand. But I can't myself say how would I build the base and then attach a metal piece to it in a way that made it effective. But I certainly think we had discussed this and just simply put it aside because of the resources available. I think it's an idea definitely worth exploring, but I would be very hesitant to do it in a way that I asked a person in one of these households to pay for it first. It's one of those things that needs a little bit of, or maybe a lot of work, and I believe the masonry is considerably more complex than the metalworking. But feel free to correct me if I'm wrong.
Thank you. And Liz?
I think this is also a question of heat. If you want to get a lot of heat out into a room, you put metal between the thing that is hot and you, and it will radiate nice heat for you. And one of the things that we have seen happen in areas of Kenya where enclosed stoves were used is that people put a secondary fire to sit around because they're not warm enough. Now, if you make a steel smoke hood, then it radiates lots of heat, and people say it's lovely and warm. If you want to make it cooler, as in the picture I think I showed from Tanzania towards the end, then you can make the walls and possibly other parts of it of mud or of adobe, which is horsehair and dung and various things built on wood. And these have been tried in the earlier study, and certainly I would feel that the body of it could be made out of such things and make it cheaper. But if you are looking to see if the actual dimensions are spot on, then the way to do it is to standardize everything else and see what happens. And the best place to do that is where people also want space heating, which was the mountains in Nepal.
Excellent, thank you. And so this is a comment really from Savannah Kapali, I believe, and who says that the Centre for Rural Technology in Nepal was involved in the first study mentioned by Liz, and they've done field studies, and they suggested a few designs for improved cook stoves to be used under the smoke hood, which address the combustion efficiency that maybe Alex was speaking about earlier.
What a fantastic piece of information. I'm sorry, I'm a consultant to this project, so you'd be much better talking to the project people in Nepal who probably know this. But this is the kind of thing we want to hear. If we can get really high efficiency stoves which will reduce the amount of fuel wood and put on a smoke hood on top, then people have got the best of both worlds, and it would be lovely if CRT was able to put some of these smoke hoods on top of those stoves and see, we're back to where, do people like them? People love these smoke hoods, which is why we've got waiting lists. And if people like them, they will buy them. If people buy them, then it becomes sustainable. So, yes, I'm Savannah, for sharing that information with me.
Excellent, thank you. And again, another question from James Fathers, who said, maybe to you, Liz, did you get the sense that once the local people saw the wide-ranging benefits of the smokers, that they took more care to adhere to the specifications of using the hood?
I don't think we've had people straying at the moment. That may be because the project is still in action, but also we're very fortunate because one of the local guys who was helping with, he was a builder's mate, decided to take and run with this, and he's been training local people. And he is of the local community, from the local community. They now want him to get involved in the politics of the local community because he is so able. And he has been helping us train, and part of that training is that if you get the sums right, then you get a smoke hood that really works. We also had a wonderful bloke who came to us and said, your smoke hood cost as much as an ox, and we thought it wasn't worth it until we saw them working, and now we're all buying them, and that's exactly what's happening. So I think they know that they're onto a good thing, and we haven't really had that problem to deal with.
Excellent, thank you very much. Sorry, just got a bit lost. Sam, did you have anything to add to that, or you?
Well, I mean, I can only speak from my own experience, having been there, and just, I mean, two major things. You know, one is that, you know, the kind hospitality of the people in the village. You know, we stayed in one of their houses, and it was more or less a double house. I mean, one of them had a smoke hood, and the other one didn't. And it wasn't just visible walking up to it. You could see the smoke as you walked towards the house. You could see the smoke pouring out the house on the right and not on the left. And you know, I was more or less told by the woman who was in the house without the hood. She said, "I bought one. When am I going to get it? I need it really, and I really, really want it." And that's just anecdotal, but that's what we continue to hear, was that there was just such a day and night difference that they just emphasized to me that it reinforced. I mean, this isn't to say that we didn't have some hiccups with certain, you know, in Nepal, to the best of my understanding, where we were, you know, the hearth is considered a religious spot, is considered holy, and to change it even in this manner was significant, and there was a need to work and coordinate, you know, with the local religious leaders and to overcome some of those issues. It also upsets me to a certain extent that the absolute poorest of families, not only they have an issue of affording they also had thatch roofs instead of slate roofs, and a thatch roof with a chimney is a danger. And so here's something also that needed to be overcome, because the absolute most vulnerable group had a situation which made it very, very difficult and questionable, because, I mean, although it's a very safe technology, one spark on a thatch roof is not necessarily something you want to risk again and again. So there's definitely a lot of things to overcome, you know, but overall, and just to emphasize what Lou said, we were extraordinarily pleased, and, you know, and right now the point is to look around and say, how can we expand this in a way that gets the technology into the hands of a lot more people who can benefit from it.
Excellent. Thank you very much. I know Liz has got lots more to say, but unfortunately we've got to wrap it up there. So I'd just like to thank Liz Bates and Sam Shiroff very much for presenting today. And please do get in touch with them or myself if you have any other questions or comments. Thank you all for attending and for your questions. Again, you can find out more at engineeringforchange-webinars.org. The PDH code for this webinar is 011020013CX. And if you have any more questions for Engineering for Change, you can email them at webinars